everyone. Thank you for joining this session. My name is Nadeem Khan. I'm a senior solution architect here at YugabyteDB. In this session, we will cover database migration solutions for YugabyteDB. We'll be talking about how one can migrate their databases to YugabyteDB using different solution approach. Before going and talking about database migration solutions, I would like to spend some time and talk on migration workflow and associated pain points with those common steps with every folks out there designed for their heterogeneous database migrations or cross-platform database migrations. Along with, we will see the common questions, and then we will be discussing the various migration approach for Yugabyte DB, and then we'll address the pain points and the questions which we had discussed, and in the last we'll see the quick demo. So with every database migration, it has its own set of complexities and challenges. And it starts with assessment and discovery phase itself. If you don't have proper resources available or inappropriate, tools, through you are not able to, assess your database completely, and you are ending up having missed data or dependencies. You are ultimately leading towards unexpected failure during migration or post migrations. So this is the first and foremost phase where you must conduct the initial assessment carefully and neatly. Then the another concerning part for most of the DBAs and developers regarding schema conversion. Obviously, when you are coming from database A to database B, the proprietary objects and data types you cannot take as it is, and you need to put efforts to convert those schemas and data types. And there you need to carefully evaluate like your database schema design. At the same time, like data modeling is a little different when it is there in the legacy database or single storage or standalone database. So there you have defined primary keys, referential integrities, but when you are taking it to distributed database like Yugabyte DB, you may not see or get the similar performance benefit with the same data modeling. So you may need to restructure or redesign your data modeling carefully. While you are doing data conversion, restructuring your schema or redesigning your data model, you must ensure that you are not losing any data. Your data integrity should remain intact. Converting data types sometime hampering your data, like missing tailing data, missing some sort of numbers or some sort of integers where you can have the differences. So you need to evaluate those part also careful. The precision loss should not be there. Performance uncertainty is another area where it is, until you are going and test your workload or replay your workload at the target database, you won't be able to get the right set of configurations for your target Yugabyte DB or any of the database, right? So there also, without running it or without understanding the target configurations, your source workload, it is really painful. And the last and foremost talking point is downtime pressure, which is always there. Everyone wants to reduce the downtime window. Everyone wants to reduce the cutover complexity. For your 24/7 mission critical database, the best you design your migration strategy, the best you can reduce the cutover, downtime and cutover. So with this, I would like to quickly read these common questions as well, which is mostly being asked by the folks out there whenever we are in field, whenever they are looking to migrate their databases to Yugabyte DB, they want to understand the different migration resources. Yugabyte DB, they want to understand whether Yugabyte DB have any native migration tool, and if it can provide the pre-migration assessment report, which can highlight the complexities in advance. and what are the tools available to convert the source schema. At the same time, like how they can migrate their database with minimum downtime and cut over complexities. Is it possible to set the real-time data replication between source and target database? Managing failover and high availability during the course of migration, and ideal, the rollback and the recovery plan for their database when they are migrating to YugabyteDB. So these are the few questions. The list is long and goes on. So yeah, we will be trying to addressing these questions also while we are presenting the database migration solutions for YugabyteDB. So in the next slide, I am going to present the database migration solutions for YugabyteDB. Like any other database, here also you can perform the migration in two different modes: offline migration and live migrations. And there are different resources are available depending which mode you are choosing. So it also depends on what type of database you have, and what sort of complexities and requirement you have with respect to that database. So with starts with offline migrations. You can leverage the YugabyteDB native migration tool, which is Voyager. It is open source tool which facilitates migration for most of the legacy common legacy databases like Postgres, Oracle, and MySQL, and the cloud variants of those databases like Aurora, RDS. You can use the YugabyteDB Voyager, which also facilitates you to perform the initial assessment for your source database, convert your schema into the target YugabyteDB format, and analyze your schema. So this is the well compressive design tool which you can leverage. Along with, there are other options are also available for the offline mode, like copy command, batch inserts, or you can use the legacy tools like pgdump or cloud migration tools like AWS DMS. One must ensure that whatever cloud migration tools you are using, because Yugabyte is Postgres compatible, so most of the tools are compatible and supported. But you need to carefully evaluate, because most of those are designed for single storage Postgres database and may not give you the best performance benefits when it comes to YugabyteDB. So after offline migration, live migration is the foremost talking point, where people are folks out there want to migrate their database to YugabyteDB with minimum downtime and cut over complexities. Again, YugabyteDB Voyager delivers you live migration. Currently, it's supported for Oracle and Postgres, and it also comes along with all those features and functionalities we discussed above with offline migrations. CDC is also supported and compatible. Sync connectors are available. You can produce and consume the data at YugabyteDB side. You can set up a real-time replication between two databases, and with YugabyteDB's Voyager and CDC, there is a robust and one solid approach comes like a hybrid database migration solutions, where you can design your database strategy to achieve the database migration in near zero downtime. So we will be discussing more on hybrid approach, where we have helped our customers and delivers the migration in actually real near zero downtime. So I would start talking about YugabyteDB Voyager, which provides end-to-end migration solutions. So this tool enables you to perform repeatable and easy migration for your legacy application database to data to YugabyteDB. It supports 4 different modes, starting with like offline migration, live migration with fall forward, and live migration with fallback approach. The latter, these two approach we will see in the coming slides. Like I mentioned, YugabyteDB provides end-to-end migration solutions, so it is well designed to provide complete database migration lifecycle management solutions, where it simplifies and automate most of the areas where leveraging that you can perform migration from your legacy database or cloud database to YugabyteDB. There are 6 key steps. It's right. It starts with preparation, where you need to establish the connectivity and installing the YB Voyager itself. Then you can move into the export phase, where you can, export the schema, analyze the schema, and then export the data. And in the next phase, you can go and import the schema, import the data, and verify it. With this, you can design a comprehensive database migration plan. So every, database migration strategy comes with some, different phases. And here you can see the migration phase starts with planning, assessing the database, migrating the database, finalizing, and cutover. That you can thoroughly design with your YugabyteDB Voyager tool, and the functionality like with CDC and other open source tools. So right, it helps in performance, perform initial assessment for your source database, then schema analysis for your source database, then it perform migration. It converts that schema into target database type wherever it requires a modification or manual intervention. It gives you that as a warning, or it highlights or outline that as a potential risk where you need a manual intervention. And it again, you can restart that migration workflow from anywhere you left it before. So this is the very special tool from you can perform the migration and design your migration strategy in a neat and flawless manner. Finalized phase is the phase where you can set up the finalized migration. Depends on which mode you have chosen. You can go for the cutover. Once you initiate the cutover, you can validate and verify your database using other various tools available with YB Voyager, like Performance Advisor is there, metrics are there, and plenty of tools are available to help you to optimize your database when it comes to target database. So like I discussed that we'll be talking about fall forward and fallback approach with live migration Yugabyte Voyager. It is nothing but the backup strategy when considering your target database doesn't work as expected, then you need some recovery plan, you need some backup strategy, and that's where this two approach helps you. With fall forward, you need to create another source replica DB, and with YugabyteDB Voyager, while it is capturing the data from your source database, at the same time, it can replicate data to your target database and another source replica DB. So once you initiate the cutover, all the connections are redirected to target database. The Voyager itself is smartly, start extracting data from target database and importing it back to source database. So you have a source DB, continuously replicated until you are sure that the target DB is working as expected. And in case of any unforeseen, you can go back to your replica DB. With fallback approach, you do not need replica DB. You have the source DB and target DB. YugabyteDB Voyager keeps extracting data from source DB and replicating it to target database. First, it takes a snapshot, and then it keeps extracting the change data capture. And then once you initiate the cutover, it automatically start capturing from the target database and start applying to the source database. So this is another backup strategy for your database while you are performing live migration with YugabyteDB Voyager. With this, I would like to talk about the augmented functionalities with YugabyteDB Voyager with CDC, where you can deliver complete, best solutions for your database where downtime window is restricted, cutover complexities are high, and you don't want to end most of your time during the downtime window. So there you can have YugabyteDB Voyager to perform migration assessment, schema conversion, and initial data load. And once it is performed, then you can set up your Kafka to perform the continuous data replication or change, data sync from your source database to target side. And you can set up the forward and reverse connector at the same time. So once you initiate the cutover, reverse connector will help you to capturing the data from target YugabyteDB and applying back to source DB. You can have the YugabyteDB provided sync connector. You can leverage the consumers and producers already provided in the GitHub library. Real-time data replication you can achieve with Golden Gate also. Golden Gate is an enterprise tool used by most of the folks and enterprises customer, and there they can also set up the replication using Golden Gate Postgres variant. Because YugabyteDB is a Postgres compatible, you can seamless connect your Golden Gate with YugabyteDB using legacy or traditional ODBC driver, and you can set up a replication. This diagram illustrates one of the topology or deployment model, but with Golden Gate there are multiple models and topologies supported, and you must carefully evaluate it for your database type and your requirement. This again can enable you to perform near zero downtime, and this is the tool behind most of the zero downtime migration tools in the market. So Golden Gate is the one reliable tool. Through that you can migrate or you can keep replicating data from your source or between two database, between any of the supported two databases with YugabyteDB. So let's quickly move to the demo.
Okay, so without further delaying anything, let me take it to the demo part. So here in this demo, we will be seeing one of the use cases with Yugabyte Voyager with live migration with fallback option. So here I have one Oracle database and one Yugabyte database. Here if I show you, this is my Oracle database, and in this database there is an HR schema, and these are the tables lies inside the database. Enough, I show you the count. So this is the current count of these tables. I have one Yugabyte database. So here, if I show you, let me connect to Yugabyte, which I have created as a target database where I need to migrate this HR schema. And if I show you, this database is empty. There is no relation inside this database. Okay, so let's quickly jump on this left hand side and let me show you the Yugabyte Voyager version. So I have already installed Yugabyte Voyager here, and this is the version installed. So with this, we can start with assessment. So like I mentioned, Yugabyte Voyager can assess your source database and help you to know what's there inside your database. So I'm going to assess the source Oracle database. You can see I have provided all the parameter details. I have kept it open just for the better visibility. You can use the YAML in some other format while you are doing it for your workload. So let me start this assessment. This may take a couple of minutes, and once it is done, then we'll see the assessment report. Okay, so here you can see my initial assessment is complete for this database. I can see the reports in the format of JSON and HTML. I can also go to my YugabyteD console, and there I can see the migration tab, and here you will be able to see the assessment report. And here you will see the complexity, your database information, what are all objects captured, the number of objects, the size of objects, the IOPS also, there on those objects. And then you will see the recommended cluster size. You will see the recommended data distribution for your objects based on the utilization and size outlined there. And here you will see the recommended changes for your different object type. You see all are here by default, like means can be automatically converted. and there is no manual intervention required. But at the same time, if you see the one of the index, I see the invalid object count. If I go and check, I will find that yeah, this index type is IoT, and this is the unsupported index for the target site. So this is the way you can analyze, you can perform the initial assessment. Once you've done the initial migration assessment, then you move to the next step where you can perform the export schema. So as a next step, I will be running the export schema, and here again, I'm going to use the same parameters for my source database, and let me start the export schema. So this will export all the object types from the source schema, and uh, let us see how it goes. It may again take a, a couple of minutes or so. Let us wait to get it completed. So super, I can see all my object types are exported. Since I haven't had a very large set of a schema or object counts, it didn't take much time. Within a minute, it was completed. So I could see the export schema files under this export directory itself, or I can come back to this screen, and here also I can see the export status. You can see the export schema, and here you will be able to see the, let me refresh this page. Yes. Okay, so next step is analyze those schema. Let me analyze the schema. Analyze is important. So once you export the schema, you need to perform the analyze, then you will be able to see. So let me analyze the schema, and with this, it is generating, oh, it is already analyzed. And now let me come back here and refresh the page, and now you'll be able to see analyze schema, right? So you could see that 29 objects are analyzed, 24 are okay to automatic DDL import, 5 have some manual refactoring requirements. So what are those? So if I go here in the procedure, you see that one is invalid object, and when I go there, you will see that unsupported PGSQL objects, and this procedure is using the percentile type. It's a PLSQL type cast operator, so that is not something you can take directly to YugabyteDB. Okay, so analyze is complete. Now I don't want, I can ignore this for now. I don't, I want to continue this migration. So I want to import the schema. So once the export and analyze is done, you can import the schema. Before importing it, let me show you again, there is no relation inside this Yuga Aura database. Here I have passed a Yuga Aura and the credentials of Yuga Aura database. Let me start the import. Okay, so import is started. You can see the import is started, and import will take a while, and we'll be back once it is complete. Okay, so here you see my import is complete. Let me come back here and see the imported schema. Yes, I can see all my tables from HR schema is imported to public schema inside Yuga Aura database. So export is done, import is done. Now we will be exporting the data. So I will be exporting the data from source database. So with this, I am running this export data from source, and I have provided all these information into this YAML file. I'm running it as a no hub because this will take an initial snapshot of data export, and then it will start capturing the all the regular changes. So here I would like to show you that I have run a sample workload. You can see the sum augmentation in employee and department tables. Oh, it is already 900, but yeah, you could see the sum augmentation in employee tables. Okay, so once the data export from source is done, we can see the export migration report. We can run this and we can see the migration reports. So this will give us clarity. Um, okay, so here we could see the snapshot rows and everything like, okay, this is the next part. So yeah, now you can see this all data is exported. So data is being exported, right? Yes. So you could see the snapshot rows, these final row counts, which are exported. Now, once data is exported, we are ready to import it to target site. So let me initiate the import to target site. Let me initiate import data to target. And let me quickly come to the target database and validate here itself. So if I come to target database and validate, oh yes, I got the entries, record entries in all the tables. Are the same. Let me run this here. Employee 590 records, employee 559 records. Let me run it again. Okay, it will take a little while. Yeah, now it is catching up. You can see the employee got 561 records. Since the snapshot done a couple of minutes before, uh, it was it is not catching. It was uh, uh, done till that time only. Now it is capturing the live data. Now you could see the both the side table has the same records. Right. So export from source is working, import to target is working, and Yugabyte Voyager is set. The as a next step, what we can do, we can initiate the cutover, and after performing the cutover, we can finalize the cutover and see. But before initiating the cutover, I will stop the my sample workload on this node, and I will match the count. So let me stop and then see the count. So I've stopped the workload, and you could see after stopping the workload, this is the final count. Here the employee is 628 records, and here also 628 records. All other records are also matching. So let me initiate the cutover. So oh sorry, I need to come to Voyager screen and initiate the cutover. Yes, I'm initiating the cutover to target, prepare for fallback true, and use YB gRPC connector true. Okay, so cutover to target initiated, wait for it to complete. Let me see the status as well. So I can see the status cutover. Okay, so cutover is completed. Once the cutover is completed, I can safely go and perform the finalize schema post data import. Let me go and perform this post data import. All right, so it is saying that Yugabyte is non-collocated database. That is perfectly fine in my case. Okay, so I have finalized the schema post data migration, and with these now I will come back to my. Is it done? Yeah, it is done. Let me come back here. The record counts are same. Let me see the record counts. Same. Okay, let me do one thing. Let me check any one of the table. Since I am not running anything here. Uh, okay, some syntax error. So this is the table. Let me insert, or let me delete one row from here. Delete from regions where region ID 6. Before that, let me validate. We have the same set of data here. because now it has started capturing from the target, which is YugabyteDB, and replicating to source. Yeah, it has the same set of rows. Okay, this is deleted. Select recent 5 values. Can I come and see here? Yeah, I can see now the replication is started to the source side. So this is how simple it is. You can perform the cutover using YugabyteDB Voyager. Post, you can see the live migration with fallback and fall forward approach. That's it. Thank you.